All right. Very good evening, everybody. My name is Pratik Agarwal, and I'm going to be your lead instructor for today's session. We have 60 minutes, and within 60 minutes, we're going to talk about a lot of things. But the main focus today is not to do all these things which are shown on the screen, but to understand how do we do step number 3 and 4. That doesn't mean that you should not learn step number 1 and 2. I'm going to give you guys a very short tutorial that I've recorded for step number 1 and step number 2, which will help you set up a cloud database on Amazon Web Services, which is a cloud platform provided by Amazon. And you can also learn in that tutorial that I will give you as a link today. You'll also learn how can you access the data which is stored in Amazon's cloud servers, right? So before we go into further details, a couple of things that I would like to quickly talk about as to what is it that we are going to cover here. One of the things that we will cover in today's session is to learn how to work with BigQuery, which is a Google's proprietary platform to run SQL queries to analyze extremely large amount of data. When I say extremely large amount of data, consider terabytes of data in a few seconds. Okay, so that's the main focus of today's session, to learn how to run SQL queries on BigQuery platform provided by Google, specifically Google's cloud platform or GCP. Now, we're talking about cloud, we're talking about database. There are a couple of assumptions I'm making that you are aware of the 3 superpowers in the world of cloud computing. For example, Amazon Web Services, AWS, which is a very well-renowned cloud platform provided by Amazon. Microsoft also has a very large cloud platform called as Microsoft Azure, and Google has something called as Google Cloud Platform. Now, a lot of people may be wondering what is the meaning of cloud. So of course, cloud, literally is something that somewhere in the sky. Here in the sky essentially means that it is there somewhere, and we are connecting to this cloud through internet. So let's say you are connecting to the cloud on your phone or on your laptop through internet. So that is what a cloud is. Now, cloud essentially is really nothing but a large data center. It is also a physical data center, which is somewhere there. And just to, if you're curious about it, and one must know about what data centers are, you can just Google data centers, right? And when you go to images, you will find these are the physical data center. This is how a data center looks like, where physically the data gets stored somewhere in the cloud. So that's what a cloud essentially means. It is still a physical place where you're storing the data, just like how you have hard drive in your laptop, you have processor in your laptop, you have graphics drive in your laptop, you've got RAM in your laptop. All those things are there in cloud machines as well. The only difference is your laptop you only own, nobody shares it with you. But cloud spaces are generally shared. You can definitely take dedicated cloud space from these cloud service providers, but generally they are shared, and hence they're cost effective. And hence cloud is what most of the organizations, small, medium-sized, big-size organizations, even the government, large government organizations, are moving their data and their processing need to the cloud instead of having powerful local machines, right? Hence, nowadays, anybody who's working with large amount of data should also be aware of how can you work with databases hosted in these cloud platforms. Any questions so far, guys? Any questions so far? Any questions at all? No? All right, great. Do ask me questions as and when you have. So today, the flavor that we will focus on is Google's cloud platforms, BigQuery, as I said before. And the reason is that, one, it is free to try, not free always, but free to try, to train yourself. Second, it's extremely efficient, especially when you're working with large amount of data. Okay, so that's what we will learn, and we will do all these things without spending a single penny from our bank account, or even without giving any credit card information to any of these cloud service companies. Okay, so the first thing that we will understand is that how do we get the data into Google Cloud Platform. I'm sure you guys have seen what data looks like in yesterday's Power BI data visualization session. So I'm not going into the details of what a data is, but I think everybody is clear about what a table in the data is, right? Everybody is clear about what tables contain as rows and columns, right? All those things are clear, everybody? Yeah?
Yes, sir, clear.
Okay. Now, just one quick thing. Yesterday, you saw Power BI. You created visualization reports, which had very nice visualization, right? So Power BI, like Tableau, like Excel, even like Python or any other such tools, this is called as a reporting tool. But in the reporting tool, where does the data come from? So the data comes from where? A very good question that somebody has asked, Subhashis has asked. Subhashis has asked, in the cloud, is there a limit on the data? Well, I always give this example, last year in Cricket World Cup, the semi-final match between India and New Zealand, right? It was webcasted on Hotstar. And there is a famous case study of Hotstar. They said that, when the toss happened, the number of viewers watching that game increased from 2 million, which itself is a large number, 2 million number, to approximately 16 million people, and then gradually it increased to approximately 25 million people watching. And everybody who's watching it, that means there is some kind of data point that is getting created. So, and then when rain happened between India and New Zealand semi-final World Cup match, then the viewer dropped from 25 million to less than 1 million. So where was the data stored? This scaling, as we call it, as a scaling, increase in the data and then the drop in the data, how does it affect the data platforms? So all this was stored on cloud. That means it was so scalable. One of the beauty of working with cloud is that you only pay for what you consume. So if you're consuming only 2 megabytes of 2 million users worth of data, then you will only pay for that much of data. You will not pay for rest of the people, and then rest of the folks also end up coming in. So to answer your questions, Bashir, the idea is that cloud is scalable. So in an abstract world, I would say that cloud is infinite, depending on if you have infinite amount of money to give to these cloud service providers. Okay. But yeah, of course, they also keep adding physical resources to keep increasing their database and their processing power. Anyway, coming back to what we were talking about, that reporting tool. So this reporting tool will get access to the data from these databases. So a database is a collection of, generally, database is a collection of tables, unless it's an unstructured data, right? And a data warehouse can be a collection of multiple databases. So imagine this is a data warehouse, right? And so that's the hierarchy. But any reporting tool, right, would require access to the database. Any human being who's trying to make decisions using data would require access to the database, right? And this access, this communication that is happening between a reporting tool and the human beings and the database happens using something called as structured query language. This is the language which databases understand. That means the software systems which allows you to create these databases, allows you to create these tables, create these columns and rows in the table, insert data into the tables. They only understand this as a language. So then the question is, which company really owns SQL? So the answer to that is, which company owns SQL then? Which company owns SQL? Any idea? Anybody? All right.
Microsoft, Oracle.
Okay. Well, SQL was designed by a couple of scientists by IBM in late 1960s and early 1970s, but then they made it open source. The reason why they made it open source was that they got frustrated with all the business users' requests for accessing data. So they designed SQL for business users who do not understand computer language much, but so that is why SQL is very English friendly, and they made it open source. That means no company really owns it. Just like English, right? No country can say that, hey, I own this language, right? Similarly, SQL is not really owned by any of these software companies which makes these database management softwares. But they all comply with this language SQL. So as a data person, if you know SQL pretty well, you can pretty much work with different database platforms provided by Microsoft, by Oracle, by IBM, by even any of these cloud service providers. You can work with any of these, right? So that is the reason why SQL is one of the top 3 skills to know for any data person. Is it making sense, guys? All right, now, what we will do is we will work with relatively large data today. And because in order to host large amount of data, you need larger space in your local machine. You would need larger processing power like the RAM and the processor power. But we will avoid all that headache, and we will use Google's cloud platform, and we will use Google's BigQuery to run some analysis or some data fetching from database by directly writing SQL. Okay, so that's what we will do. A couple of we will perform the steps together. For Google BigQuery, the first thing that you need to do is, let me first show you how the BigQuery looks like as an interface. So this is an interface of Google Cloud Platform, and this is an interface of BigQuery that we will be using. How do we go to this interface is something that we will learn now. What you need to do is just go to Google and search, right? Google BigQuery Sandbox, this one. I'll put it in the chat window as well so that you guys know what we are searching for. Google BigQuery Sandbox. Sandbox is like a trial box, like a trial environment, not a production environment, but a trial environment, right? And then the first link that you get, which says quick start using the Google Cloud Console, click on it. And when you click on it, you want to scroll down and you want to go to something called as query a public data set, right? And then click on this button. I will wait for a confirmation. If anybody is facing any problem, let me know. Can you all go to Google, look for BigQuery Sandbox, come to this page, the first link that you get, and scroll down all the way to query a public data set and go to BigQuery. Is it done, everybody? Anybody facing any issue at all? Done? All right, good. Now let's go to BigQuery. When you click on it, now mine is already logged in, and hence the interface that I may see may be a little different than yours. You may be asked to, you'll have to log in with your Gmail. Once you log in with your Gmail, then you will see that there is a place to select the project. I will make one of you as a volunteer, and I would want to see what are you able to see. So who would like to volunteer, and I'll make you present your screen. Arya, do you want to present? Arya, who has Somebody who has stable internet connection can present. Arya, do you want to present Arya as Kumar?
Actually, sir, I am on my mobile and
All right,
this is my computer.
No worries. Somebody who's on laptop. Quickly. Alexander.
Oh, yes, sir, I can listen.
Yeah, go ahead and share the screen, please. All right, guys. I would like everybody to focus on what is happening on Alexander's screen. So Alexander, this is the place that you came, right? After logging in. Yeah. Now keep your mic on, Alexander, so that you can respond.
Yes, sir. Yeah.
All right, great. Now click on this dismiss over here. We are not worried about that trial thing. So we will click on dismiss. It's dismissed. Now, what we want to do is we want to create a project. Okay, just to give you a description of what we are doing, we will create a project. It's like a folder, master folder. Under that project, we will create something called the data set, which is nothing but a database. Google calls database as data set. And within that data set, we will create tables. So that's what we will do. So how do we create a project? So in SQL workspace here, click over here, which says create project. Do you see this? Yeah. Now give a unique name. Since we are going to work in the first project that we're going to work is COVID project. So no, you can't give an underscore here. You can give a hyphen. See, and it has to be unique. Something which is going to be unique. No other person in the world should have the same. COVID, maybe write some, no spaces are allowed. I'm not sure that generic name will take it. So write some numbers as well. Hyphen number or something like that. Okay, let's see if it takes it or not.
This one fine, code one.
No, remove the hyphen at the end.
Okay.
Let's see, create. Okay, it took it. But remember, no two people can give the same name. So you got to give something unique. And then it's going to take a few seconds. And so what it is doing behind the scene is essentially it is creating a new project for you. In the free version, you can create up to 12 projects, which is more than enough. Just click on done. Now, we are here. Now, if you notice here, what we have is COVID-1 project, right? This is the project that we have created. Now, if there is a drop down here, click on that drop down. Now, there is nothing in this drop down because we have created the project, but we have not created any data sets. So we want to create the data set next. So click on these three dots. Click on create data set. All right, just a quick milestone to check. Anybody facing any issues so far? Okay. And if you're doing it on the phone, I'm going to share the recording. It's going to be uploaded on IB's YouTube channel as well. And you can see the recording there as well. Now, this is the project ID. We don't want to change it. Give a dataset ID. Now here the underscores are allowed, but no spaces are allowed. So let's call it as COVID analysis or something. COVID underscore analysis. All right. Data location, just in the drop down here, select US multiple regions. So essentially we are saying that this data set that we are creating will be stored in one of the data centers somewhere in the US. Table expiration, we're not worried about it. Just click on create data set here. All right. So what we have done here now is we have created our first data set. The name of the data set is COVID analysis. Got it? Now, what is the next thing that we should do, Alexander?
Create tables.
Create tables. Now, where are the tables? So if you notice in your chat window, in Zoom chat window, I've given a link to download a table.
Yeah.
So can you go to Zoom chat window, download that CSV file, comma separated values file, which contains the data. Yeah, download it. It's a little large file, 88 MB. As I said, we wanted to work with larger data set. So it's going to take, few seconds only, I think. All right, let's open that. Yeah, you got right click on that file just for a moment, the first file that you downloaded. Right click and go to properties. Is it a CSV file or not?
It's a CSV file.
It's a CSV file. All right, great then. Okay, great. CSV file is a comma separated values file. It's not a Microsoft proprietary file, although it opens by default in Excel, but that is the common file which is used in the industry to migrate the data from one platform to another. Close this. We don't want to open it in Excel. It might just hang it. It's a large data. Now, see, this is also one of the reasons why we are not working with Excel here, because it's extremely large. Excel can easily crash with such large data. What we want to do is, we have created a data set, but we want to create the tables. So the next thing that you want to do here is click on these three dots against the data sets, because the tables go inside the data sets. Click over there. And did you click on it? Alexander, are you there?
Yes, sir. Yes, sir. Yeah, my connector good. Yeah. Create table.
Yeah. Now it says create table from empty table, but we are not going to create it from empty table. So click on this drop down here. The drop down is on the right hand side. Are you there? Yeah. Now go to, not go to drive, but go to download from upload. Select the file, so browse for it. Absolutely. Yeah, good. CSV format, and now COVID data sets. The table name, give it an easy table name. Let's call it as COVID. Yeah, native table. This is an important thing to do. Auto detect the schema. Now, just for a moment, let's discuss what a schema is. Schema is essentially whenever you load or create any table, the table will have columns in it. Columns meaning these are the attributes or the fields of the table. For example, the first column is an ID column. The second column is a name column. The third column is an email column. Fourth column is, let's say, salary column. Fifth column is, let's say, date of birth column, and so on and so forth. If you notice, these different columns would contain different types of data. ID may contain an integer data. Name may contain character data or string data. So would email. Salary would contain, again, integer data, maybe decimal as well. Date of birth will contain date data, date or time data. And let's say there is a status column, which basically says whether scored status or not. So it's a yes no column. So it's a binary column. All these things, all the definition of the columns, as we say, are called as schema or metadata. which basically means data about the table, right? So looking at these column data types, you can say what kind of data will be stored in which table, which column, right? So when we say auto detect the schema, then Google's BigQuery will actually open the file that we're trying to upload, will actually read each and every column and understand the kind of data that is there in each and every column and automatically assign the data type as per the nature of the column that we are uploading. Is this making sense, everybody? Yeah. So we will go with auto detect. Now come down, click on create table. I know it gives an error, but do not worry about it. Do not worry about it. It just because this is sandbox environment, it's a trial, test environment. So that is why it's been throwing this error. But believe me, in a few seconds, you will get that the job is completed and the table is created. So what it is doing behind the scene, why it's taking a few seconds to do it, because one, the table is large, so it is reading the schema, it is loading the data, 88 MB of data. See, now it says load job created. That means we have loaded the data, inserted the data. So remember, it was a large data file. So that is why it took a few seconds to load. Now, just close this. There is a close here. You can also cancel it. Yes, say yes, quit. Got it? Now, where we are. So just a quick knowledge check. What all have we done, guys, so far? What all have we done? Who can explain what all we have done? And what is the next thing that we should be doing? All right, Devesh, what do you think? Somnath, what do you think the next thing that we will be doing? What do you guys think? Interesting. Come on, tell me. Anybody? No? Nobody?
Use the COVID dataset.
Absolutely right. Query it. Sanjukta, you are absolutely right. We want to query the table that we just loaded. We want to see what is there in that table. And then we will see, what kind of analysis that we can actually do. So let's see what's there in this table. How can we see that? Again, these three dots are there. Let's click on this three dot and let's say query, open. Let's open it. Let's open it. Now, what it does is that it opens the table. The first thing is showing the schema. Schema will show all the fields which are there. So just scroll down for a moment. You will see people, positive cases, province name, state name, country name, county name, report date, data source name, people that new count, all this kind of data that is there, right? Go up, go up, go up. Let's see. So these are the kind of data. Now let's preview the data also, which will show a few rows from the table. Now, if you notice, people positive cases count in this county names, US county, in this state name in the US. This is the reporting date. This is the continent name. This is the data source name, New York Times. People that new count. Just scroll down here, scroll right. Scroll right. Yeah, so if you notice country short name, country alpha 3 code, country alpha 2 code, people positive new cases, all these fields are there, people that count and whatnot, right? Now, let's see how do we send a query, instruction to this table, in fact, instruction to BigQuery platform of Google that I want to fetch some data from this project, this data set, and specifically this particular table. How and where do we write the query? So you see there's an editor tab which is already open. Else, you can also query here, or you can query by clicking on these three dots. So wherever we want to query this table, so click on query wherever, either here or on the three dots. So in a new tab, query in a new tab. So now look at your first query, how it looks like. It says select some spaces there, then from, then What is this? Now, this is important to understand. The first thing is what? This is your COVID-1 hyphen project is your project. Then this is your data set, if you remember. And then this is your table. And this entire string, like a path, like, you know, you have folder path in your computer, C drive, then folder name, subfolder name, and so on and so forth. So it's just like that. This is put under pair of ticks. Ticks is a number one, is a symbol before number one in your keyboard, just below escape. Check your keyboard. There is a single quote kind of a symbol, but it's not really a single quote. It's called as a tick, which is like this in number, just before number one in your keyboard, right? Now, this is the syntax followed by the underlying database in Google's serverless BigQuery platform. Google's BigQuery platform is based on a famous database management system called as MySQL. Hence, the SQL that works very well with MySQL database management system would most likely work with Google's BigQuery platform as well. But so far, are we clear what this string denotes here? Everybody, are we clear about that fact? You know, what is this string denoting? The project, the dataset name, and the table name. Is everybody clear on this part? All right, Alexander, you've been a good pupil today. You know, you're doing exactly what I'm telling you to do. Very nice. Now, let's look at this couple of things. You know, this select is like read. We want to read the data, right? That means whenever we say we want to query anything, you have a business query to answer, right? That is a query. We convert that query into a SQL query or SQL query, which databases can understand. So let's say we want to read the data. From where? So this from basically means, so select from and then where. This is the basic construct of read query or select query from any database management system. So from this project, from this data set, from this table, limit 1000. Why are we limiting 1000 records here? Any idea? This 1000 essentially means, remember, this table is a large table. It may contain a lot of data in it. And as I said, Google BigQuery is a cloud platform by Google Cloud Platform. Hence, they charge on uses. They charge as per uses. That means if you run a query which is going to run on larger data, right? Then the bill to run this query, the amount of dollar to run this query will be also more. Hence, we try and optimize the query by saying that, all right, we are interested in 1000 records. Now, it is giving me a syntax error. You can see it is giving me a syntax error. Select list must not be empty. Here, the reason why we are getting a syntax error is after select, before from, we have not written what column do we want to extract. So let's go to the COVID tab here, Alexander. Let's see what columns are there. Let's go to the COVID tab here.
Where, sir? Where? Oh, here.
Yeah. Now let's see. I want to check how many COVID cases were reported in the continent USA. Okay, how many COVID cases were reported in continent America actually. So let's go to the editor. And let's write. Okay, in fact, now let me do it. Let me share my screen. Thank you. Okay, I'm going to dismiss this and I am going to come down to the, alrighty, where is my data gone? Okay. It is somewhere I loaded. Oh, all right. I loaded in the wrong project. Well, I loaded in on my another project. So anyway, so select. Okay. Can you guys see my screen? Maybe not so much. Let me increase the size. Yeah. So some question being asked, what is the need if SQL was made to make the process easy? Why do we have so many forms of SQL? It's like English, you know. Why do we have so many different types of words in English for the same object, right? So you know, I mean, different people, because it was open source, so a lot of different people started to adopt it little bit. Just like, you know, how if you go to Australia, your English may be a little different from, you know, when you're speaking English in the US, right? It's the same thing, same philosophy. Different companies have created database management systems, right? They all know that they want to comply with SQL, but they put a little bit of flavors into it. And that is the reason why you have little flavors, differences in SQL. But believe me, if you are good, see, I started my career in Oracle, then I moved my career to SQL Server, then I moved my career to MS Access, then I moved my career to MySQL. Then, I mean, so again, I moved my career to Oracle, then to BigQuery. So literally, the only thing that was common in my professional journey was SQL as a language. So that is the reason why you know, you have so many different flavors. But again, at the same time, if you know SQL in any one of these, if you know any one of the flavors of SQL in any one of these database management system, you are pretty good to go. Anyway, select from, right? Now, after that, we want the COVID data. So let me see. I have to put it under pair of ticks, cricket, this one, right? Dot, see, dot is like, you know, like a backward slash in your folder path, dot. And then I would want to write the dataset name. What should be my dataset name? So COVID underscore in, see, dot. Then there is table here, COVID, right? Now I say limit 10 records. Semicolon is like period in English statement, full stop. Select what all fields. Let's say I want to select all the fields. Then I would write an asterisk, star. And then to run, I will select everything. And then I will click on this tab, this button here called as run, or I'll press Control Enter to run it. So when I run this query, then I will get result here. You can see the result. Now this result is a little hidden, so I will just make it a little bigger, the result tab, and you can see the result. But this is just the table. And if you notice, the query took 0.3 seconds, and this much MB of data was processed. Now, even with this limit of 10 records only, it processed 112 MB of data. Now notice here, guys. Notice, right? If I remove the limit, all right, there's not much of difference here, but yeah, at times, you know, if you're not putting the limit, it will end up taking a lot more memory to run. So here I have selected all the fields from the table. What if I want to select specific fields only? So let's select specific field. Let's say I am interested. So I have written some queries. So we will look into some of those queries right now. Let me copy these queries for you. Bring them into my workspace here. Control V. Now, if you notice, the question here is, how many distinct continents does this data set cover? Distinct continent. And if you notice, this statement I have written under pair of / asterisk and */ anything that you write under this pair is used as comment, meaning they will not be treated as English, they will not be treated as SQL statement, but will be treated as plain English statement. How many distinct continents? So if I write select from, then I write this entire cricket analytics dot covid underscore in dot covid, that's my table name, and semicolon, and then I will write distinct. See, there's a keyword called as distinct, and then distinct what? Distinct, it says continent names. So in our database, in our table, it's called as continent name. See, this is the beauty of BigQuery. It shows it tab, and then you select it. And then you run this statement. And what you notice here, bring this tab a little bit up. What you notice is that these are the different continents which it represents, the data represents. Now let's look at the next question. It says, find the total number of positive cases in counties of Georgia. And look at the, let's dissect this query a little bit, yeah? Or maybe I can write it for you again, no problem. I'll just note down the from this. It says, find the total number of positive cases in counties of Georgia. One of the things that I have noticed, which always helps when you're running SQL queries, especially on large data set, is that try and create an ideal output. So the ideal output here will be what? Total number of cases in counties of Georgia. So Georgia is a province name, right? So there'll be county name, and then it will be number of cases. So let's say county name 1, county name 2, and so forth, and count. Is it making sense? Group by. Why are we grouping? Because we want to get county wise details. So group by county. So we have something called as county name. Group by county name, and then county name comma count of star, or not count of star, but positive number of cases. So sum of, see, sum is a function, just like in Excel you have function. Sum of positive cases. If you go back to this table, suppose if I open just to see the fields in this table, if you notice here, there is something called as people underscore positive underscore cases underscore count. That is a field. So sum of, what should I write here, guys? Any idea? What should I write here? Sum of what should I write? Any idea? What should I write? People. That's right. People with whatever that field name was, which is people with positive underscore cases. People, positive, new cases, count, or cases count, actually not even new cases count. Cases count as total cases. Now it said that we want data only for which I mean, for Georgia. So Georgia, if I can go back to the table thing, here there is something called as province state name. Province state name is like a state name. So where province state name is equals to Georgia. Look at this. Select from where group by. That is the basic construct. From this table, code table, where that means only those rows which meet this criteria. It's like filtering in Excel or Power BI, filtering, you know. Then such rows, we want to group them by which column? We want to group them by the county name column. And once we have grouped them by county name column, then we want to find the sum of total. So that's what we will do. So we'll select this and run it. And when we run it, oh, it says query done, no name. I mean, no data, which is a little surprising because when I ran this query, it gave me the data. It's the same query that we have written there. Okay, all right. Maybe Georgia is not a is not a province name. Okay, let's try. Suppose if I remove it and I run this query, let's see what data we get. Yeah, so you can see county name, and this is getting, so maybe Georgia was just not a province name there. So if you, so you get you get the idea that from this table, this group by. Now you guys will help me with this query. How many new cases can be seen before the year 2022? What should we do, guys, here before the year 2022? Any idea? What should we do? Any idea? Any suggestion? Anything that we should do here, guys? Any suggestion anywhere? Any suggestion? All right. So people are saying that we should use where condition somewhere, and also what we should do is we should somehow write this less than 2022. And what should be less than 2022? If you notice here, there is a column here called as report date. So what we need to do is that in that case, select from this table, of course, where report date is less than 2022-01-01 under pair of double quotes, because it's a date value. Any value that we use in the where clause or anywhere in SQL statement, which is non-numeric, we put that under pair or double quotes in Google's BigQuery SQL. So if you notice, from this report date is this, is less than this, people with positive new cases, and then you will get this. So this is showing you date wise. So this is the date and this is the number of positive cases which are before number 2022. But the question is slightly different. how many new cases in total can be seen, how many new cases in total. So what I'm going to do is that I'm going to write sum of this, and then I'll remove the report date because I don't care about the report date, as total new cases before 2022. And then I select this statement and I run it, and it'll give me how many values, guys. How many values will we get? How many rows will we get as an output of this query? Any idea how many rows will we get as the output of this query? Alexander, you're right. So we will get only one. Excellent. So we will get only one here. So if you notice, we get only this much, which amounts to be 225 crore. That's a big number. 250 million people before 2022. Right? Now let's do a last question for the day. What is the average number of cases observed in Asia? Average number of cases observed in Asia. Average number of cases, average number of monthly cases. Let me modify the statement a little bit. Average number of monthly cases observed in Asia. So if you notice, we want month-wise data, right? If I were to create the ideal output, then I want in one column, I want the month and I want the total count of cases in the second. I'm doing a some monthly analysis that if there is any correlation in the months or not. So select from where continent name. Let's copy this. Is this go to Asia, group by. There is a function here called as extract month from report date. So this function will extract the month only, month portion. And this comma count star total cases. This should have been where. And it is running, and it ran. Oh, well, it returned nothing. Continent name is Asia. Let's remove this for a moment. Let's see if it is working. By the way, if you can't see the results here, it's maybe the screen is zoomed into, right? So if I zoom out, you can see the result. So this column here is your month column. And you can see the number of cases per month. And the best part is you can save the results as a CSV file. And then once you bring that data into a CSV file, you can open it in Power BI, in Excel for further reporting. So you got the cases here, right? And then let's say you sort the data by, and then you can visualize it into this visualization tool, which is Excel. So that's also a beauty of working with Google Cloud Platform, that it allows you to do this. Now, look at this question here. Which date has recorded the maximum death count? So here we will use report date max from and then you can figure out report date max people dead count, and then you got the okay, all right, sorry, not max here. Here we will figure out this, what is the number of deaths date wise, and then look at this, I am going to order the data. Order meaning sort the data by people death count in DESC, descending order. See how easy it is to sort the data. DESC, descending order. And when you sort the data in descending order, and then if you say limit by 1, automatically the date which will be at top will only show, and that date will have the maximum reported deaths. So this is the date. In fact, 17 Jan apparently had the maximum. So this is actually people that count total cumulative, and I'm sure there is a column here called as new death or something. People that new count, and I think that is the one that we should have used. People that underscore new underscore count. That would probably give you a better visibility, because the other one is a cumulative number, total number, cumulative. Or that's in this data, it seems like this is the number that is still there. All right. Okay, guys. So that's what I had for you today, guys. So what are the things that we have learned today? What we have learned today is that what is Google Cloud Platform? How do we access it? How do we load the data? How do we create a project? How do we create a data set? And how do we load the data from local system without worrying about the size of the data, right? And then they've also learned how do we run these basic SQL queries on Google BigQuery Cloud Platform. As I had promised you at the beginning of the class that I would give you the link to tutorial link to understand how to create database management or how to host databases on Amazon Web Services as well. So if you go to Ivy's YouTube platform, I would suggest you subscribe subscribe to that, and then this is the video where I've actually explained how do you load or how do you host database on Amazon's web service, and this is where okay, people that new count, that makes sense. I think that's what Sanjukta, thank you for correcting me here. I should have sorted the data by this particular column, and I was sorting the data by the wrong column. Let's see if it changes our date. Ideally it should. Yeah, it does change. So this is the date when we had significant amount of new deaths. Thank you, Sanjukta. Thank you for correcting me. One of the other things that you can also do, by the way, guys, with Google BigQuery is you can explore this data, visualize it, take it into Google Data Studio. You can Google and understand a little bit more about Google Data Studio. It's almost like Tableau and Power BI, a little less powerful, I would say. But yes, you can play around with it. Similar things like how you would have created a dashboard yesterday. You can actually also create dashboards here. You can create charts here. That could be an interesting thing to explore as a next step, guys. Yeah, and it's very, very easy to get this data, put into Google Studio, Data Studio to explore the data further. Alrighty, guys. So as I said, this video is getting uploaded on Ivy's YouTube platform as well, guys. So if you're there, please go and like that video and subscribe to Ivy's YouTube channel. And for the people who are interested more about learning cloud and how do we work with large amount of data on cloud and what are the things that we do, Ivy has recently launched a very new program in collaboration with industry companies, and it's international certification program along with NASCOM and Government of India, and it's called as Cloud Data Engineering Certification Program. Please feel free to explore it on Ivy's website. You'll find all these things, and along with this, you'll find a lot of things on what all we can do for real-time data analysis on Google, on not just Google Cloud Platform, but on Amazon's Cloud Platform and Google and Microsoft Azure. And that also prepares you for international certification. So that is what I had for you guys today. Look out for the video on the Ivy's YouTube channel, and I will see you guys when I see you next. I will also upload these scripts that I have given here, or that I have used here in the chat window, as well as I will put it as a description in the see. Okay, somehow it's not going there, but I will put it into a as a file on YouTube channel, guys. See you guys. Take care, everybody. Bye-bye. Have a good one. I am here for the next 5 minutes, guys, and I'll be more than happy to answer any of your questions on data science, data engineering, and or today's workshop. And if you want to get connected with me, if you just Google my name, Pratik Ivy, the first link will be my LinkedIn link, and the second link will be my Twitter link. These are the two platforms where I'm pretty active at. I'll be more than happy to get connected with you. Anyway, I'm here for the next couple of minutes, guys. Should you have any questions, feel free to ask anything at all. All right. If you guys do not have any questions, then I'll see you guys when I see you next. Have a good night, and do watch the video again. Do practice on what we learned today, and do attend tomorrow's class, guys. Tomorrow's class is going to be an exciting class because I'm going to talk about what are the different steps to follow in order to make a promising career in data engineering. Bye-bye. I'll answer all the queries tomorrow as well on career and related stuff. Take care. Bye-bye, guys. Good night.
Thank you, sir. Good night.